All right, hey guys, Mr. Kyle, Myers Mathematics, and today I want to talk about the second triangle. And when I talk about the second triangle, to give a little bit of context, hopefully the description in the video helps, but when you are looking for a second triangle, this is only when a specific scenario happens in pre-calc when you're doing some trig stuff, and you're on usually law of sines and law of cosines. So this is going to be under law of sines, law of cosines type problems. And for a certain triangle, if they give you a side and an angle, and there's a couple other stipulations, then there happens to be two actual possible triangles that can be created from that side and that angle. So let's go ahead and look at how to tell, and we'll look at an example problem, and that is what I want to do today. So let's go ahead and dive right in. Before we get started, if you haven't already gotten my free guide, it's the 5 math mistakes everyone makes and how to avoid them. It is fantastic. I mention the first one to my private tutoring students all the time. It's negative signs. Negative signs is the probably number one thing, the individual thing that people miss, is just those negative signs, man. Bringing people down. So let's go ahead and look at when there is a second triangle. So what I'm going to do here is create what I like to call, well, it is called this, but I like to use the fancy term because it sounds cool. It's called a dichotomous key, which basically just means that I'm going to kind of ask a question and then it's a yes or no answer. If the answer is yes, I move on. If the answer is no, I do something else. So I'm going to do this off to the side over here. The first question we want to ask is, we want to know, is it a side-side angle triangle? So, is the triangle or info given side-side angle? And we can figure that out because if it's side-side angle, then you'll have a side angle pair, and then you'll have another given side. So for instance, I could know, let's say angle A is 80, and then the side A is 2 and B is 3. This is a side-side angle because I have a side angle pair, A and A. It doesn't have to be A, it could be B and B, C and C. I have a side angle pair, and then I have another given side. Now this other given side doesn't have to be B, it could be C. It doesn't matter because it's a triangle, so B and C it doesn't really matter which one it would be. Okay, you have a side angle pair, and then you have another given side. That's how you know if it's side-side angle, if they just give you this info. If they give you a triangle, then you should be able to look at the triangle, right? So I have a side, let's say this is 3. Actually, that doesn't even look like 3. Let me go back. That looks like a 2 maybe. That's a little bit more accurate at least. So 2 and then 3, and then the angle across from 2 is 80. All right, and that doesn't look accurate, but you see what I'm doing here. So it would be the side, the angle across, and then another given side. Okay, obviously not trying to scale here. But that's the first question you want to ask. So if the answer is yes, then we move on. If the answer is no, then we're going to do something else. And I'm going to tell you what that other thing is in a second, because when we answer no to any of these questions, you basically default to this other thing. Okay, so that's our first question. This is number 1. Is it side-side angle? If it's not, we do not have 2 possible triangles. All right, so moving on to the second question. If the answer is yes. If the answer is yes, we have gone to question 2. Question 2, we want to know, is the given angle, so is the given angle acute? Right? Is it acute? And then, of course, the answer is either yes or no. Yes or no. If it's 90, it's right. If it's more than 90, it's obtuse. And they're not going to give you an angle. Hopefully, that's 180, because that wouldn't make any sense. You can't make a triangle with a 180-degree angle. But if it's acute, then we move on. If it's no, like I said, we would go and default to this other option here. Is the angle acute? That's it. Pretty simple. Step 2 is actually the simplest step to identify because you just figure out if it's acute. If it's between 0 and 90, we move on. If it's not, then we don't. Right? So on to step 3. Now, step 3 is the hardest one, and if you have a better way to word this, if you're seeing this and you're on this topic, and maybe your book words it really nicely, let me know in the comments how they word it, because I would love to see how to word this better. But here's the best way I know of to word step 3. Here's what we need to do. We need the side across from the angle has to be, or I guess I should word this as a question. I should say, is the side across? I forgot to word it as a question. I would fail at Jeopardy. Is there we go. Your answer must be in the form of a question. Is the side across from the angle less than the other side? Okay, so I feel like a picture would help with this. So let's say we have some sort of line going on here, and we have some sort of given angle. Right, so here's my given angle. And let's say this angle is, it looks like about 60 or so maybe. And then let's say this side right here is 10. Okay, so is the side across from the angle less than the other side? So if the side across from the angle, which I haven't drawn yet, so let me use a different color for that maybe. Use orange. Side across from the angle less than the other side. So if I have this happen, let's say, right? You can tell that that's going to be less than 10. Right? I'm just kind of sketching this, so we don't know exactly what that is, but it's going to be less than 10. You can kind of tell it's a little less than 10. So let's say it's 7 maybe. Okay? So if it's 7, if the side across from the angle is less than the other side, then I could potentially draw 2 of them in 2 different ways without messing with the side or the angle, the 10 or the 60. The 10 and the 60 do not have to move or grow or do anything for me to draw 2 different 7s there. And this is how you make 2 triangles. So that's why step 3 is really important. Is the side across from the angle less than the other side? Right, so other side. Okay, and then of course this is also a yes or no question. So it's either yes or no. So yes, we move on. No, we don't. Okay, and the last step. So there's actually 4 steps. Okay, so we do potentially have 2. From the very start, we have potentially 2 things going on here, right? So from the very start, we could potentially have 2 triangles. If we answer no to any of the questions, we do not potentially have 2 triangles anymore, okay? So the 4th question. 4th and sort of it's the final question, but that's not the final step. So the questions are also kind of steps right now. Last thing. We want to use the law of sines. And I know this is not a question, use law of sines. Okay? So I guess there's only really 3 questions, because in order to figure out whether we actually do have 2 sides, the last thing we need to do is use law of sines. Okay? Use law of sines to figure out the other angle. So, you're given 3 bits of information, a side, and an angle. The side and the angle are an angle-side pair. So you're going to be solving for the angle that corresponds with the other given side. Okay? Use law of sines. And then this is what happens when you use law of sines. Okay? You have 3 options. Either you get an error, so you're going to be using a calculator, right? Because, it's law of sines. You're going to be finding the sine. Unless they give you like 30, 60, 90 type angles or something. You're going to be using a calculator for this, right? So if you get an error, right, it's going to say error. And it'll say quit or go to if you're using a graphing calculator. If you get an error, then there are 0 triangles. That's it. It's actually the same thing for regular problems. If you get an error message, assuming you typed it in right, there's just no triangle that's possible to be made. And that just happens sometimes. Sometimes they just give you some funky numbers that don't actually make a triangle at all. And that's just how that is. So if you get an error, 0 triangles. Boom, done. Just it's a little bit of a letdown because you almost want there to be 2 triangles at this point. It's kind of a weird feeling maybe where you're like, oh, I've gotten this far, I should have 2 triangles. And then if you get an error message, you're like, oh, well, I guess I don't have any triangles, it turns out. Okay, oh, well, I guess I'm done now. So it's like you're glad that you don't have to keep working, but you're also kind of let down. Anyways, so error, 0 triangles. If I get 90 degrees exactly, or, pi over 2 if you're in radians, then I have exactly 1 triangle possible. 1 triangle. If I get exactly 90. If I get an acute angle, though, so if I get an answer that's between 0 and 90, so between 0 and 90, not including 0 or 90, obviously, if you include 90, it would be a right angle. It gives you 1 triangle. If it's 0, that would be an error. You can't have a 0 degree angle in a triangle. So between 0 and 90, then we have 2 triangles. 2 triangles. Don't try my angles. Okay, so if you have error or 90 or 0 to 90, and I'll let you think about that for a second because I don't know if you noticed, but there's no option for obtuse angles here. And that's actually on purpose because if you have an acute angle, it's going to result in another answer being the obtuse version of that. So that's what happens there. You're not going to get an obtuse answer, and I won't go into why in this video, but essentially it has to do with if you have 2 triangles, then you'll have an acute and an obtuse version. So there is an obtuse angle that exists, but it won't. The calculator will default to the acute answer, not the obtuse answer, even though there's 2 answers. So you kind of have to get the other one yourself. Okay. So if we do have 2 triangles, then we get to this step. If we get to this step, then you subtract that answer. So subtract, this is like step 5 here. So subtract that angle from the law of sines, that is, subtract that angle from 180 to get the other angle for the other triangle. And then you use that information to solve for everything else. All right, and that is how you do that. So let me zoom out a little bit here. Let me zoom out a little bit. If you have a second triangle, we have some questions that we ask. Notice we left the nose kind of blank here, but this other thing that happens here is sort of this. You kind of skip right to step 4-ish. So I'm going to say step A, because I don't really know what else to call it. But whenever you get a no answer, you kind of do step 4. You kind of do step 4, except there's only 2 things. So this is sort of like 4, maybe 4. I can call this 4A. If you get a no answer here for step 1, 2, or 3, then here's what you do. You use law of sines, and then basically if you get error, then it's the same thing. If you get an error, then you have 0 triangles, right? Assuming you typed it in right. 0 triangles. Triangles. For some reason, only the number 1 is singular. Every other number is plural. I don't know if you ever noticed that, but it would seem like 0 would be singular, but I guess it's not because it's not 1. Anyways, so error, 0 triangles. And then if you don't get an error, literally any other number, literally, oh my gosh, I can't spell. Literally any other answer, put angle, same thing. Literally any other angle, then you have 1 triangle, and you just solve for the other stuff. Okay, literally any other angle, and you get 1 triangle. Sorry, that's kind of sloppy. And you just keep solving, and you just go about your business. All right, so let's look at a side-side angle triangle. We'll kind of build the scenario here. So I'll use maybe purple to end this out. So let's say the angle is 70. And let's say the A, because we need so we need the angle to be acute, and then we need an angle side pair, and we need two sides. One of them being A. Maybe the other one will be B. Okay, so we have an A and we have a B. Okay, so we need, let's see, we need the side across from the angle less than the other side. Side across from the angle needs to be less than the other side. Let's say it's 8, and B is 9. Okay, side across from the angle, 8, has to be less than the other side, which is 9. So yes, there we go. So I just kind of created a problem that is side-side angle with an acute angle, and a side across from the angle, 8, less than the other side, 9. All right, so then we use law of sines. So we would do sine 70 over 8 equals sine of B over 9. And if I solve this, I'll kind of just do the quick maths here. This would be, actually, I don't even need to do cross multiplication here. I would do multiply both sides by 9 and then take the inverse sine of both sides, sine inverse, and that would solve for B. So let's see what that is. Of course, when you're typing this into your calculator, make sure you're in the right mode. I'm in degree mode, so we're good here. We're using degrees. Sine inverse of 9 times sine of 70 over 8, close parentheses, enter. I get error, which actually is not spelled out ERROR on my calculator. I'm using a TI-84 Plus here. I get an ERR, so I'm sorry, I forgot to misspell error. My bad. But I get an error. So that means that what I just created here doesn't actually result in a triangle at all. I get an error message. All right, so that was the end of that problem. Let's do this a little differently. Let's say this is 8.5 now, because I decided. Okay, let's say that's 8.5 now. So let's change this to 8.5. See if we can get two triangles out of this. Sine inverse of 9 times sine 70 and divide by 8.5. There we go. Okay. So when I do it like this and I change it to 8.5, I do get an acute angle. So B is 84 point blah, 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 blah. I'm just going to round to 84. So it's 84. Okay. Now that's B1. So now this is just a specific value for a specific triangle. Now to get the other one, I would subtract from 180. All right. I need to borrow there. So that's going to be a 9. So 96. And you want to add it back just to make sure. Anytime you do math by hand and not in the calculator, I mean, obviously I could have just used the calculator, but whatever. So if you want to check it real quick, if you do math by hand, just check it to add it back up or whatever and make sure it adds up. So anyways, the other angle would be 96. So 96 is the second B angle. It's the second B angle. So then I can figure out what C is for both. So I just do 180 minus 84 minus 70. And that gives me 26, so C1 is 26. I just found the third angle by subtracting from 180. Every triangle's angles have to add up to 180, so I just do 180 minus 70 is in both triangles, because that's an initial given. 180 minus 70 minus 96, and I get 14. So C2 is 14. And then I can just use law of sines again to figure out what C is, the length C. So I just need one more bit of information. I need the length C for both of these. So this is lowercase c. I just wrote C2 again. It's supposed to be C1. Yeah. So this is uppercase, and this is lowercase c for the side length. So for both of those, I set them up the same way. I could just use the sine 70 over 80 or 8.5 thing again, because that's the same in both triangles. And then I just use my C values. So it would be sine 26 over C, and then the same thing for the other one. So I can cross multiply here. This would be 8.5 sine 26 over sine 70 equals C1. So 8.5 times the sine of 26, close parentheses, divided by sine 70, and I get 3.96. I'm going to just round that to 4. So that's 4. And then the other one is going to be almost identical. It's going to be 8.5, but then the sine of 14. 8.5 sine 14 divided by a sine 70. It's going to be exactly the same except for that one value, because the 8.5 and the 70 numbers are initial values, so they don't change. And I get about 2. 2.1 blah blah blah, so about 2. I'm doing some intense rounding here. Normally you round to like 2 decimal places or something. But there you go. There's your 2 triangles. You could draw them out to see what they look like, but they look like this. Right? They look like this, and you've probably, if you're on this unit right now, you've seen this topic, and they look kind of like that, okay? Where you'd have one triangle like this, and the other triangle is right here. Okay? So there's your 2 triangles. They look roughly like that every single time. One of them's acute, one of them's obtuse. Actually, sometimes they're both obtuse, but one of them is definitely obtuse. So anyways, I hope this was helpful. If it was, go ahead and like, subscribe, all that good stuff, and I will see you guys again very soon in another